Though there are more than 400 clinical treatment trials underway, currently there is no specific proven therapy for COVID-19. And we should not expect a vaccine or effective antiviral drug to be available anytime soon. Although we are developing COVID-19 vaccines at pandemic speed. Just for reference, the average vaccine takes more than a decade to develop, with an average failure rate of 94%. Many have asked me for advice on what they can eat to help bolster their immune system. How not to die from infections is, after all, amazing studies like randomized, double-blind trials showing, for example, that eating broccoli sprouts can reduce viral loads for influenza, decrease virus-induced inflammation, and boost our antiviral natural killer cell activity just from eating some broccoli sprouts. But this isn't the flu. I certainly support general common sense advice to stay healthy during the crisis, put forth by trusted authorities such as the American College of Lifestyle Medicine. This includes getting sufficient sleep, 7 to 9 hours, keeping active, reducing stress, staying connected, albeit remotely, to friends and family, and eating healthy, a diet centered around whole plant food. The World Health Organization agrees. Fruits, vegetables, legumes like beans, split peas, chickpeas, and lentils, nuts, whole grains, cutting down on sugars, cutting down on meat, dairy, and junk, and cutting down on salt. Optimal nutritional status for a well-functioning immune system is an important factor to protect against viral infections. However, one must resist the urge to jump on the snake-oily spam wagon of foods to boost your immune system, given our near total ignorance of the immunological aspects of this new disease, because enhancing specific arms of the immune system could hypothetically even make things worse. Let me explain. Take the example of this married couple, both same age, admitted to the hospital on the same day for the same COVID-19 infection, fever, shortness of breath. Tragically, the wife was immunocompromised because she was on chemo for breast cancer at the time. Yikes! Whereas her husband had an intact immune system. The wife did fine, though, out of the hospital in under a week, whereas the husband ended up in intensive care. Wait, the immunocompromised patient did better? How is that possible? Well, because unlike other common viruses, coronaviruses have not shown to cause a more severe disease in immunosuppressed patients. Why? Because your own immune response appears to be the main driver of lung tissue damage during infection. Starting around the second week of symptoms, the virus can trigger what's called a cytokine storm. It's like an autoimmune reaction where your body overreacts, and in attacking coronavirus, your lungs get caught in the crossfire. In the first week of the illness, it's the virus itself that's triggering most of your symptoms. But then in severe cases, it's our own inflammatory response that takes over in causing most of the damage. It's striking that many of our innate immune signaling pathways, these cytokine chemical messengers our immune cells release, is aimed at killing off our own cells. But that makes total sense. The virus turns our own cells against us into little virus factories, so it's part of our own antiviral defense to kill off our own cells to dead-end viral replication. Viruses can't replicate in dead cells, so cell suicide is like a way to create fire breaks. But in burning down the village in order to save it, we may not survive the process. This has led some to consider immunosuppression as a treatment for severe COVID-19, but of course immunosuppression for hyperinflammation in COVID-19 might be a double-edged sword. So when you see like broccoli sprouts can whip up natural killer cell activity within 2 days, is that a good thing or a bad thing for something like COVID-19? I mean, it was good for seasonal flu, but who knows with this new coronavirus? Young children have relatively immature immune systems that normally suffer disproportionately from viral infections such as the flu, but not apparently from COVID-19, or SARS, or MERS, for that matter, the other two deadly coronaviruses. It's interesting. One theory as to why children seem protected suggests that greater pre-existing exposure to common cold coronaviruses offer kids some cross-protection against the new virus. But ironically, a competing theory suggests it's their lack of exposure to similar viruses that's safeguarding them. There's a phenomenon known as ADE, antibody-dependent enhancement, a phenomenon first described more than 50 years ago. In most cases, the antibodies our bodies make to target pathogens neutralizes them, or at the very least, tags the invaders for removal. Sometimes, though, antibodies can actually facilitate viral infection and exacerbate disease. This may be the case with SARS, where antibodies generated against the viral spike proteins were sometimes found to promote infection. In monkeys, an experimental SARS vaccine resulted in aggravated lung damage. Now, vaccine developers are well aware of this phenomenon and would work to ensure any commercial vaccine would be free from this failing, but it has been used to venture a guess to account for the unusual age distribution of severe COVID-19 cases. Perhaps similar coronaviruses circulated silently decades ago, and those old enough to have been exposed to them are now experiencing exaggerated responses to COVID-19. But young people never saw them, so they don't get the overreaction. I'm not suggesting this speculation is true, I just use it to illustrate the complexity of it. Given the uncertainties, the best strategy is to not get infected in the first place, especially not until effective treatments and a functioning healthcare system are